Welcome to AI Agent Academy. I'm Sophia.
I'm Yomen.
And today we're doing a deep dive into something fascinating. LLM parameters, the control knobs of AI and optimization secrets.
That's right.
So if you've ever wondered why an AI can sound super precise 1 minute and then, completely off the wall creative the next, well, you're in the right spot.
Mm-hmm.
We're going to look under the hood at large language models, LLMs, and specifically how you can tweak their behavior using these parameters. Think of it like your personal control panel for the AI.
Exactly. At their core, LLMs are basically prediction engines. They work with tokens, parts of words, whole words, punctuation.
Right.
And their main job is just predicting the most likely next token. So if it sees the quick brown fox jumps over, it's calculating the odds for lazy, dog, fence, whatever.
Okay.
But the really cool part is these parameters we're talking about, they directly mess with those probabilities. They let you steer the output from super predictable to really exploratory.
Okay, so when you want a specific kind of output, maybe really precise or maybe totally wild, what's the first knob you usually reach for on that panel? And, why that one first?
Definitely temperature. It's the main one for randomness, for creativity. People call it the creativity thermostat.
Yeah, I like that analogy.
And it fits pretty well. What temperature does is it scales the raw prediction, scores the logits before they get turned into probabilities.
Okay, so it changes the weighting.
Exactly.
Yeah.
It adjusts how strongly the model prefers the top choice versus, slightly less likely choices. Higher temperature gives those less likely options a better shot.
Gotcha.
So let's break down what that actually looks like.
Yeah.
If you set a low temperature, maybe 0.1 to 0.5, it makes the high probability words even more dominant. The output gets really deterministic, very predictable, consistent. Great for facts, technical stuff, legal docs.
Right, where you need accuracy.
Precisely. Like if you ask it to describe a rose flower at temp 0.3, you'll get something like, a rose is a woody perennial flowering plant of the genus Rosa. Very straightforward.
Okay, factual.
Then there's medium temperature, maybe 0.7 to 1.0. This is often the default, like in ChatGPT. It gives a good balance, sounds natural for general conversation.
The sweet spot for chatbots, maybe.
Kind of, yeah. Then you crank it up to high temperature, say 1.5 or even 2.0.
Uh-oh.
Well, it flattens the probabilities. Less likely words get a real chance. So the output becomes diverse, creative, sometimes really surprising. Good for brainstorming, marketing ideas, poetry.
Uh-huh.
So that same rose flower description at temp 1.0 might sound like, bathed in moon mist, the velvet rose unfolded, its crimson deeper than a forgotten dream, each thorn a tiny secret. Much more imaginative.
Wow, okay, that's a huge difference. So low temp for sticking to the script, high temp for exploring new ideas, but like you hinted, maybe not too high, or it just starts talking nonsense.
Exactly. There's a point where it just becomes incoherent. You have to find the right balance for your needs.
Right. Okay, so if temperature is the overall heat of creativity, what about this top P or nucleus sampling? Sounds like another way to control diversity, maybe a bit more subtle.
It is, yeah. It offers a more dynamic control, I'd say. So how top P works is the model looks at all the possible next words and sorts them by probability, highest first.
Okay.
Then it takes only the top words whose probabilities add up to the top P value you set. So if P is 0.9, it keeps adding words to the list until their combined chance hits 90%.
Ah, so it creates a smaller pool to choose from.
Exactly. A nucleus of the most likely candidates, defined by that cumulative probability. The next word is then chosen only from within that nucleus.
Interesting. How does that change the output compared to temperature?
Well, with a low top P, like 0.1 or 0.3, the nucleus is tiny, containing only the absolute most likely words. So the output is very conservative, focused, precise. Again, good for technical or legal stuff. With a high top P, like 0.7 or 0.9, the nucleus is much larger. It allows for more variety of vocabulary and phrasing, leading to more creative, diverse outputs.
Okay.
The key advantage, I think, is that top P adapts dynamically. The size of that nucleus changes based on how peaked or flat the probability distribution is at that moment. So it tends to produce creative text that feels a bit more consistent, less likely to suddenly throw in a really weird word out of nowhere compared to just cranking up the tempo.
So it's still creative, but maybe less erratic.
That's a good way to think about it.
Yeah.
Using our rose example again, low top P, 0.2, gives you a factual, concise description. High top P, 0.9, might give you something rich, descriptive, even poetic, but it's less likely to suddenly start talking about, I don't know, dragons.
Okay, I see. So temperature is like the overall volume of creativity, and top P is like a smart dynamic range compressor, keeping it focused while still allowing variation. Adaptive.
Yeah, that's a decent analogy.
And we should probably just quickly mention top K too, right? Is that similar?
It is similar in goal. Yeah,
Mhm.
top K just picks a fixed number of the top words. So top K10 means it only considers the 10 most probable words. It's simpler, but generally seen as less nuanced than top E because it doesn't adapt to the actual probabilities.
Yeah.
You don't see it exposed as often in APIs like OpenAI's, for instance.
Got it. So top P is usually the more sophisticated choice there. Okay, so we've fiddled with the creativity dials. What about setting boundaries? Like
Mhm.
just telling the AI how long it should talk or when to stop. That seems pretty fundamental. Let's start with max tokens.
Absolutely critical. Max tokens sets the hard upper limit on the total number of tokens in the prompt plus tokens in the generated response.
Ah, prompt plus response. Good point.
Yeah. And it's super important for a couple of reasons. One, it stops the AI from just rambling on forever, which can happen. Two, and this is key for anyone watching budgets,
Uh-huh.
it directly controls API costs. Fewer tokens generated means a smaller bill. Simple as that.
Okay, so for our DevOps folks listening, this is a big one for managing that cloud spend.
Definitely. In practice, you might set max tokens low, like under 200, for summaries or short answers. For
Mhm.
longer stuff, like essays or code generation, you might need 1,000, 5,000, maybe more, depending on the context window.
Right.
So if you ask, what's the capital of the U.S., and set max tokens to 10, you might just get Washington, D.C.
Mm.
Increase it to 100, and you'll get a much fuller description.
Makes sense. Control the length, control the cost. What about making it stop at a very specific point? That's stop sequences, right?
Exactly. These are defined strings of text. When the AI generates one of these sequences, it just stops, and immediately. Doesn't matter if it hasn't hit the max tokens limit.
Okay, a hard break. Why is that so useful?
Crucial for integrations and structured data. Imagine you need the AI to output JSON. You can set the closing curly brace as a stop sequence.
Ah, clever.
Or for code, maybe the closing triple backtick, so on.
Yeah.
Or even just formatting lists, maybe stopping at the next number or ending an email with sincerely. It ensures the output is clean and predictable, ready for parsing by another system. No extra rambling afterwards.
Yeah, that avoids a lot of messy cleanup later. Like if you just want one sentence, you could use a period as a stop sequence.
You absolutely could. Write one sentence about roses,
Right.
set as the stop sequence, and it should stop right after the first period it generates.
Very useful. Okay, moving on. Let's talk about repetition. Sometimes AI gets stuck saying the same things over and over. You mentioned these next two parameters are like the spices to control that, frequency and presence penalty.
That's a good way to think about them, yeah. They help manage repetition and
Mhm.
encourage novelty. Let's start with frequency penalty.
Okay.
This one penalizes tokens based on how often they've already shown up in the text being generated. The more a word has been used, the higher the penalty for using it again.
So it actively discourages repeating the same words.
Right. The typical range is Metage's 2.0 to 2.0. Positive values reduce repetition. Negative values actually encourage it, which you usually don't want, leads to really monotonous output.
So is frequency penalty basically like telling a noisy service that keeps spamming the same error in the logs to just cool it for a second?
Huh. Yeah, that's actually a perfect DevOps analogy. It tells the AI, hey, ease up on repeating that word. It pushes it to find synonyms or rephrase, leading to more varied vocabulary, especially in longer texts.
Got it. And what about the other spice, presence penalty? How's that different?
Presence penalty is simpler. It penalizes a token just for having appeared at all in the generated text, even once. Doesn't care how many times, just whether it's present or not.
Ah, yeah.
Same range, NIGA 2.0 to 2.0. Positive values encourage using new words and concepts that haven't been mentioned yet. Negative values would make it stick to topics already introduced.
So promotes novelty more broadly?
Yeah, it encourages introducing new ideas or terms rather than just varying the words used for existing ideas. The key difference. Frequency scales with how often a word is used. Presence is a one-time penalty once a word appears.
Okay, so frequency penalty stops the AI from sounding like a broken record on one specific word, while presence penalty encourages it to bring new records to the party altogether.
That's a great way to summarize it. Both aim to reduce repetition, just via different mechanisms.
Right. We've covered a lot of individual knobs here. Now, the tricky part, how do they work together? Because you're not usually adjusting just one, are you? This sounds like where the real art comes in, finding that perfect harmony.
It really is. Temperature and top pay are a classic example. They both influence randomness, but differently. Adjusting one definitely impacts how the other behaves.
So you can't just max out both and expect perfect creativity.
Probably not. You might get chaos. OpenAI, for instance, often recommends just adjusting one of them from the default to start, precisely because it gets complicated quickly.
Okay. But what if you do adjust both? What are the pros and cons?
Well, the pro is definitely enhanced flexibility. You can get really fine-grained control, tailoring the output very specifically. You
Hmm.
can sometimes mitigate extremes like high temperature for creativity, but a moderate top pay to keep it from going completely off the rails.
Okay, so more nuanced control. What's the downside?
The cons are increased complexity, definitely. It's harder to troubleshoot if something goes wrong. You might get conflicting effects if you're not careful. There's a risk of overfitting your settings to just one type of prompt, and it just takes more time and effort to tune.
Right. More knobs means more ways to mess it up, potentially.
Potentially, yeah. But for advanced users, some combinations are common. High temp plus high top P for maximum brainstorming power, low temp plus low top P for ultra precise, predictable text. Or maybe moderate temp and moderate top P for that balanced, coherent, but creative output.
It really is finding that sweet spot. Okay, so what about when things do go wrong? Because, they do. Any tips for troubleshooting common problems using these parameters?
Oh, definitely. As someone who spends time debugging systems, you'll learn to look for patterns. These parameters are often the first place to check.
Makes sense.
So if you're getting incoherent or nonsensical text, too much randomness is usually the culprit.
Hmm.
Try lowering temperature, reducing top D, maybe bump up the presence penalty to encourage focus.
Okay. What about repetitive stuff?
Repetitive or circular content. The AI is stuck. Increase temperature a bit to introduce variety, and definitely increase the frequency penalty.
Got it. Off topic.
Off-topic or irrelevant responses often mean it needs more focus. Lower top P, maybe lower temperature slightly, but critically, look at your prompt. Make it more specific.
Good point. Prompt is key. Factual errors.
Factual inaccuracies.
Yeah.
This is a big one. You need to reduce randomness significantly. Lower temperature way down, like 0.2 or 0.3. Reduce top P too. Force it to stick to its most confident, hopefully correct predictions.
Right. Lock it down. Inconsistent tone.
Inconsistent tone or style.
Yeah.
Stabilize temperature and top P. Don't have them fluctuating wildly. And again, use your prompt.
Yeah.
Guide the style explicitly, maybe even provide examples.
And if it just stops too early?
Truncated or incomplete output. That's usually the easiest fix. Just increase your max tokens limit.
Okay, that's a great cheat sheet. And you mentioned prompts a few times there. It sounds like these parameters don't replace good prompt engineering. They work with it.
100%. They are synergistic. Great parameters won't save a bad prompt, and a great prompt can be undermined by poorly chosen parameters. You need both.
So best practices for prompts still apply. Be specific, give context.
Absolutely. Be specific, provide context, iterate on your prompts just like you iterate on parameters, and use examples in your prompt whenever possible to show the AI the format or style you want.
Right. So when should someone stick with the defaults versus diving into all this customization?
Defaults are fine for simpler tasks, quick tests, or if the task is very standard and aligns well with how the model was trained. If it works, don't fix it.
Mm-hmm.
But you really need to customize for specialized content, legal, medical, highly creative stuff. Also for complex tasks, optimizing performance or cost, maintaining consistent brand voice, or ensuring safety and ethical guidelines are met. That's when tweaking these knobs becomes essential.
It feels like mastering these parameters really gives you a much deeper level of control, almost like understanding how the AI thinks or chooses its path.
That's a good way to put it. You're influencing its decision-making process at a fundamental level, guiding how it navigates the huge space of possible word combinations to get you the result you actually need.
Okay, so let's quickly recap. We've explored the key LLM parameters, temperature, the creativity thermostat, top EP, the dynamic filter, max tokens for length and cost control, stop sequences for structure, and the spices of frequency and presence penalty to manage repetition and novelty.
Mhm.
The big takeaway seems to be that understanding and using these control knobs is crucial for moving beyond generic AI output. It's about tailoring the AI's behavior for your specific needs, whether that's creative writing, factual summaries, coding, or anything else. And experimentation is key.
Absolutely. Iterate, test, refine.
These controls let you fine-tune the AI precisely. So the final thought for you listening is, how might you use these subtle but powerful controls? What new possibilities could they unlock in your projects? Could they solve a problem you've been stuck on or maybe spark some unexpected creativity? See you in the next